Okay, so now we start in on the conic sections. So what we've got is a cone, right? Double-sided cone like that. This cone, if we cut it up, gives us our conic sections. The first one, if we cut straight across here, we'll get a circle. All right? If we cut on an angle like this, we'll get an ellipse, not an oblong. All right? This is an ellipse. There's no such thing in mathematics as an oblong. This is an ellipse. If we cut like this, we will get a parabola. If we were to cut on that line, it would be straight. So straight lines actually are part of conics, but they're not the conics we're interested in. And the last one is if we cut a straight line down here, we get two bits. One that looks like this and one that looks like this. And that's called a hyperbola. We're going to be looking at each of these separately. Today, we're going to start with circles. The formula for a circle: x squared plus y squared equals the radius squared. That's our standard formula. Right, so if we looked at a circle and we had it coming out 2, like that, so that's going through 2 and 2 and negative 2 and negative 2, then we've got x squared plus y squared equals 4, 2 squared, right, radius squared. But our circles don't always stay hanging on the origin, the centre point of our axes. So we have to be able to move these around, and we learned how to do these a little bit when we were learning about graphs last year. So if we want to move x this way or that way, we actually put a number in the brackets with x. So our general formula is x minus some point, what do I want to call that some point, plus y minus, I'm going to call it p actually, p and q equals r squared. That means the new centre is at PQ, whatever that coordinate happens to be. We've still got the radius squared, and the centre will move from that point, but we need to remember that it can be written like this. Now the problem here is that we want to write it like this, and sometimes it's not given to us like this, it's given to us in a big long equation that looks somewhat like this. Now to draw this, we have to be able to find the centre and to find the radius. So we need to do something called completing square. Now you had a little look at this last year in algebra. This time it's a little bit more complicated because we're going to look at it as this one and this one, and we're going to put the number over here. So we're going to complete the square on this one, complete the square on this one, then we'll have our information. So remember, we're halving this, x squared plus, oh, not x squared, x plus 1 squared. So what will that give us? That will give us x squared plus 2x plus 1. We got an extra plus 1 out of that. So if we've got an extra plus 1 here, we need to add an extra plus 1 over here. So over here we have negative 1 plus 1. That's that 1 there. Because it wasn't there when we started. We've made it. To keep it balanced, we add it to both sides. So this one plus y minus 2 squared. What does that expand to? Y squared minus 4y plus 4. Got an extra plus 4. We need to put it on this side also. So we add 4 as well. So what we've got now is x plus 1 squared plus y minus 2 squared equals 4. Therefore, the centre of our circle is at negative 1, 2, and the radius, remember it's got to be change signs, is equal to the square root of 4, which is 2. Alright, so we've got to learn to be able to complete the square on an equation to find out what our circle looks like.